Hi, Doc Revis here with Watch Me Work It. This is a Hess's Law problem that's a bit more challenging than some of the other Hess's Law problems you might see. So watch me work it. Here's a problem. Find the delta H for the reaction given the following reactions and values. So here we have the base reaction that we're interested in. Here's the first one. And here are the ones from the table. Okay? So we're going to take a look at this base reaction, and we want to find what delta H is based upon these equations. So here's what we do. First, we take a look at the base equation and see if we can match it to some of the equations. And keep in mind the compounds have to be on the same side. So in the case of our base equation, or at least our target, we'll just call this our target. Okay. For our target equation, we know we have C2H2O on the left side, on the reactant side. So we find an equation that has C2H4 in it. And yep, in this case, equation number 2 has it already on that side. So we're going to simply rewrite that equation. Okay? Because it's on the side that we want it to be on. Rewrite everything that's in there just as you see it. I'm going to omit the phases right now. Okay. So we rewrite that equation because we see the C2H4 on the left side. Here we have it on the left in this equation here, equation number 2. So we have C2, we have two COs, two CO2s. So we have two CO2s plus two H2Os here. And since we didn't change anything, we would simply write that enthalpy, that delta H, just as we see it. No changes. Joules. Okay. Next, we'll take a look and see what other components we have. We have water on the left side here. Okay. Now, I tend to skip water and oxygen if I have something else in there. So I'm going to skip and go straight to C2H6 on the right side here. I'm going to look for the equation that has C2H6. There it is right there. C2H6, we have it. But it's on the left side. I need it to be on the right side. So that means I'm going to have to flip this equation. So when I flip this equation, I'll flip it, and what I'll have is, I'll rewrite it, just rearranged, flipped, or reversed. CO2, again, I'm going to omit the states, plus 3H2O. That gives me C2H6O, okay, plus 3O2. All right, exactly what I see. Now, since I flipped that equation, okay, I have to change the sign. So now that sign is going to be now positive. It was a negative. Now it becomes a positive. Okay, so it becomes 685.5, okay, kilojoules. And let me correct this. It should have been kilojoules, not joules. Okay. So we flip the equation, and this is what we get. Now, the next thing we're going to do is see whether or not things are balanced here, okay? So we flip the equation, and we have it set up with a plus and a minus, and we're going to go back now and inspect the equation to see how many of each of the elements we have. Well, in the first one, we use equation number 2. But if we look at number 2 versus the target, we should have a 2 here. So we have to multiply everything here times 2. And this times 2 also. Occasionally you'll see me wrap it around the entire value as well. So either way you like to show it. So we have a 2 there. And we also notice for C2H6 we have a 2, so we have to put a 2 here. Times everything inside the equation, and we have to say 2 times this value as well. All right. Now from here, it's up to you how you do your math. You could do it in stages. You can do it just with your calculator doing the work. So this would be 2 times this number and 2 times this number. But we need to check to see if this adds up to our equation. Now, I can write this entire equation down, or I can go ahead and cancel out things that are very common. You do your cancellation like you do in math, left side, right side. What I observe then is that I have, if I do my cancellations, on this side, I have a total of 4 CO2s because I'm multiplying 4. Up here, I have 4 CO2s. So those will cancel out. Okay. In the case here, I would have 5 oxygens here. Okay. And here, I would have a total of 6 oxygens. 4 times 2 is 6. And waters, I would have 4 waters here. And I'll have 6 waters here. So what I'm going to do is sum this up, but right away though, let me clean this bad looking H2O up here, okay? This looks really out of place. There we go. So I went through and I did these cancellations, and when I add this equation up, and this is just a matter of adding up what's left, okay? When I add this equation up, I see that it worked out pretty good. I get my target equation. I get 2C2H4O. We have 5 oxygens here and 6 oxygens over here. So these oxygens are going to cancel out right here, and this is going to cancel down to 1 oxygen there. So I have C2H4O, no oxygens here, but I do have water on this side. But look, those waters get canceled down too. This goes down to 0 waters over here. We get 0 waters over here, and over here we get these cancel down to 2 waters. Okay, so that works out nicely. So I have this plus 2H2O gives me 2C2H6O plus O2. Now I have confidence that this works out. I just do the math over here. If you run this math, however you do your math, you'll come out with 204.0 kilojoules. Okay, so we get the kilojoules there. All right, so that's how we do that one. Now let's do another one here. Same process. We take a look at the target reaction. So this is our target reaction, and these are table reactions, and we're going to match these up against the target, these table reactions. So we're going to take, these are table reactions. This is our target, okay? And we're going to match our target, these table reactions to our target, okay? So let's go through each of them and do it. So just starting with nitrogen, since it's first up here, we'll write out the equation for nitrogen. We see that nitrogen here and nitrogen here, they're both on the left side, okay? So since they're both on the left side, we could start and just write that equation up, right? So here we would write into, I'm going to omit the stages just for speed here, plus hydrogen. That will give us 2NH3, and we didn't change anything there, so its value is minus 115. Just simply read it since we didn't make any changes to it there. Next, we're going to go ahead and see what else we have here. We have O2, but I tend to work with the NO2s next. And here's the equation. Equation number 2 has NO2 in it, and its NO2 is in the right place again. I tend to leave oxygen and waters to do them last. Okay, so I can simply use equation number 2 just as it is written. So this would be 2NH3 plus 4H2O. Again, just omitting the phases. only because it doesn't impact the math. Plus 7H2. And since I didn't make any changes to that, okay, I can just simply write that number too. So it's going to be minus 142.5 kilojoules. Next, I'll go through and I'll try to cancel things out and put things on the right side. But here, you notice what I need left is oxygen before I can do that. So I need to get oxygen on the left side. And this equation with oxygen is equation number 3. I see my oxygen in equation number 3, but it's on the right side. It needs to be on the left. So I'm going to flip this equation. If I flip this equation, I'm just putting oxygen first here. Doesn't matter which order, as long as it's on the proper side of the equation. Just the product flips to the reactants. I call it flipping, or you can call it reversing. And I get H2O here. Okay. And now that value, I flipped it, so that value was a positive. Now it becomes, it was a negative. Now it becomes a positive. Just circle it so you can keep an eye on it there. So it becomes a positive, all right? So that's what you got to keep an eye on, is that positive. So that's positive 43.7 kilojoules. Now I want to start to balance this equation out. And I notice that my nitrogens are already balanced, so I'm not going to touch the first equation. If I go to the second equation, I know that my nitrogens, my NO2s are already balanced out. This is a 2. Let me clarify that, just in case that doesn't look like a 2. I think I might have typed a 3. That's a 2. Okay, so I notice these are balanced out, so I'm not going to touch that right now. If I go down to the oxygens, however, I see I have 2 oxygen in the target, and here I'll have 1/2. So this equation has to be multiplied times 4. Okay, to get this. All right, and so I'm going to say times 4 here. Occasionally I will bracket the entire thing and do it, but here I flipped it and I had to multiply times 4. And if I do this and I run through my math, I get minus 83 kilojoules. Okay, so that's how you work some of the more challenging Hess's law. You line them up, then you make sure everything's on the proper side. Make sure if you flip or reverse the equation, you flip or reverse the sign, and then you multiply through to balance it. And now, just to be sure, to show you that it works out, if I go through and show you these cancellations, if we have any, oh, look at there, it just turned into 4 times that turns into simply 2. Okay, this turns into 4 hydrogens here, and this turns into 4 waters. And if I do my cancellations, the hydrogens, there's a total of 7 on this side, and there's a total of 7 right here, so those canceled out really well. If I look at my waters, I see water, 4 waters, 4 waters, and I get my target equation. I can do that, or I can write this entire equation out long and then do the cancellation. And that part's up to you. But if you do it, you'll end up with exactly what you want. It was N2 plus 2 O2s will give me 2 NO2. And all works out nicely there, because if I got show you my other cancellation, is these canceled out as well. Okay, so watch for all your cancellations. You can write this as one long equation, or you can do it if you can visually see the math here. Write one long equation, cancel left and right side, and you're done. All right, so that's how you do it.